Hi. Welcome to day 2 of React Rally. Did you all have a good day yesterday? All right. Well, feedback aside, I am here to do a talk on accessibility and React that is partly inspired by my childhood. Wow, that's really nice. I grew up playing a game called Where in the World is Carmen Sandiego, which is a super rad way to learn about geography, if you were not familiar with this game. There was also a TV show. So how many people remember Where in the World is Carmen Sandiego? So in my work in accessibility, JavaScript frameworks, and developer tools, I've sometimes been confused about why something doesn't work or what objects are available in a new context. To try and keep you from running into the same problems I ran into, we're going on a little adventure.
Where in the stack is Carmen Sanfrancisco?
Wow, that was really loud. Hello, and welcome to Acme. I'm Marcy Sutton, but you can call me the Chief. We're in the business of tracking down culprits of JavaScript confusion. We're ultimately after well-architected web development tools, orchestrating processes across the computer stack, and producing the most accessible websites ever. Every bug we'll ever chase down will be for the goal of making the web more inclusive for all. Now, Gumshoes, when you report for duty, I'll assign you a case. You'll go to the source and look for clues about where we are in the stack. That's where the chase begins. Any bystander is a potential witness who can help point you in the right direction. When you finally catch up with a rogue process, you've got to put a stop to it. We have 25 minutes to solve these cases, or we'll be confused forever. So are you ready for your first case? Our first mission will take us to the home of hypertext and the World Wide Web, a place in the stack we love for its reach, openness, and archivability. Ah, yes, the browser context, where we have built-in JavaScript objects like document and window, CSS styling, semantic HTML, and developer tools. Browsers have evolved quite a bit since the 90s. Let's give that a second, feedback. This is where your job starts. A front-end developer from Reno said he had trouble binding focus in a dropdown, which, left broken, would be a severe accessibility issue for keyboard and screen reader users. Gumshoes, we better get this one right. People with disabilities are depending on us. Let's take a look at a React drop-down menu that's causing trouble in IE and JAWS, a popular screen reader on Windows. The developer said he added code to send focus to the first item when the component opens, which is a common technique in focus management. This ensures the user's keyboard focus is in the right place when the menu opens, and it will announce it in a screen reader.
Tab, trigger button menu. Enter. Enter. Enter.
Well, that didn't work. Why wasn't focus sent to the first item? Let's look at the code and try to catch the culprit. In this React component, the trigger link has a populated href and 2 ARIA attributes that indicate it controls something. ARIA has pop-up and ARIA controls, which just last week there was a really great article by Hayden Pickering called ARIA Controls is Poop, talking about sport. Shout out to Hayden for writing a blog post that got me to say that in a talk. But if you're curious about that attribute, it does help users in Internet Explorer, so that's the group we're trying to help with this component, so that will bind the anchor to the dropdown that it opens. In the dropdown component instantiation, 2 listeners are set up for the show and hide events. These events actually hook into a third-party library from Atlassian, AUI, which we can't swap out this quarter. In the dropdown show event listener, the developer tried querying the DOM and sending programmatic focus to an anchor, which looks like maybe it should work since anchors are natively accessible with the keyboard. But as we observed, the focus did not land on the item in the dropdown. So what's up with that? Let's see if we can gain any insight by asking an expert witness, Cameron Cundiff, developer at Thoughtbot and organizer of Ali NYC.
If I were you, I'd check to see if the element was focusable. And don't forget to test it with screen readers.
So it seems there are a number of potential culprits to the focus drop. The developer sent focus to an anchor, but it didn't have an href attribute, so he added one. It should now receive focus since it has an href attribute. Tab index also works depending on what element you're working with, but be aware there's a little more that you might have to do if you're adding tab index to a div, for example. But this anchor still wouldn't focus, so that's not it. When you tried opening it with JAWS, the screen reader focus was dropped every single time. But it sometimes happened with the plain keyboard too, so maybe it's not JAWS's fault. What's going on here? I'm guessing it's a visibility race condition because the menu wasn't yet open by the time we tried to send focus to it. Layering JavaScript event handlers on top of the AUI dropdown in this case causes a race condition, where the dropdown is ultimately rendered visible by another script that we don't control. This can be a problem for screen readers and keyboards, which need elements to be accessible and interactive to send focus to them. To solve this, make sure the element is actually focusable. Use an anchor, make sure it has an href, or you could use a button if it's not navigational. You could also use the tab index attribute, as I mentioned, to make any element focusable, but you might need to expose different semantics. That said, if you know your ducks are in a row and it is a focusable element and it still won't focus, which has happened to me, make sure the focus event is wrapped in a callback on React render. That will ensure it isn't called until the component is actually rendered, and then you can send focus to it. I've also seen this solved with set timeouts or watching a property or an attribute that changes the display, or something that you know is the thing you're actually changing. But this is where React does a really great job at this because you have more control and you can really send focus at the right time after you're sure that the element has been rendered. So now that we've uncovered this culprit, let's take another look at the dropdown now that it's fixed.
Tab, trigger button menu. Enter a -thing.com link. Use JAWS key plus Alt plus M to move the controlled element. A thing.
A thing. That's a really useful link text. So the real fix for this, we solved it by putting the focus event in a React render callback, but the real fix would be to ditch the third-party library completely and write it in a more pragmatic way so that you wouldn't have this delay between the scripts they're like missing each other as you fire them. But we don't always have that luxury in the real world. That's happened to me where I can't swap out the underlying third-party library and I need to still make it accessible. Knowing that this is how keyboard mechanics work is a really valuable tool when you're getting into accessibility. It's also worth mentioning there is a bit more to dropdowns if you're looking to create one. There are UX considerations like trapping the focus in it once it's open so that the keyboard or screen reader user can't get lost behind it. You can also consider whether to make it more like a desktop menu or just keep it as a list of links. For more on accessible dropdowns beyond JS frameworks, because this is a pretty common UI pattern, I've bookmarked a classic post by my friend Terrell Thompson, which you can find on just the subject at bit.ly/Thompson-dropdowns. If you're interested in building accessible React components, check out the work from David Clark up on GitHub. He's got a React ARIA menu, a modal dialog, and a tab panel that are built completely with accessibility in mind. There are also a few repos on the React.js GitHub account that you can check out, an autocomplete and a modal, and those have really great test coverage if you want to see how to work on that. But these are known UI patterns that you can find all over the web, so finding good examples is good inspiration if you're looking to see how this stuff is done to be accessible. Now, if you feel confused working on accessible dropdowns, you're not alone. They're frequently a mess on the web, and there were a lot of really terrible dropdowns when I was putting this talk together. And it's really in response to the fact that we don't have the control we need to style elements like select. We just don't have the primitives to have full style control, so people move to custom implementations. But there's more that we need to consider, obviously. We need to think about focus management. We need to think about trapping focus if it's a modal dialog, so you can't get stuck behind it. But we've uncovered some of the keyboard mechanics at least for custom dropdowns. So now that the word is out, we can each do our part to improve focus management from now on. And we can even automate testing it. Gumshoes. We need to expose information about objects in a user interface. We're looking for an important mapping for understanding hierarchy and context. Can you help find it? Okay, all right. When you start coding for accessibility, it might be unclear what's happening under the hood. You might wonder, how can I make form inputs work with a screen reader? What are these role and ARIA dash attributes I keep seeing everywhere? And do screen readers look at the DOM, or is there something else going on? Let's ask Alice Boxhall, software engineer on Google Chrome and creator of the Chrome Accessibility Developer Tools.
I heard there's a platform alternative to DOM scraping that produces a tree of objects with role, state, and name.
That's pretty vague, but I think we have all the clues we need for this case. I can tell you we aren't necessarily in no JavaScript land because assistive technologies do use JavaScript. Otherwise, I probably wouldn't be here talking to you at a React conference. The HTML element API is the interface for elements, but it handles many things not related to accessibility, so it isn't really the right place either. We're close to way ARIA, the spec for standard accessibility attributes in HTML and SVG. ARIA provides a collection of standard accessibility attributes which are used on various platforms. It's an accessory to our suspect, but not what we're looking for. What about accessibility APIs? There are accessibility APIs in most modern operating systems that expose information to screen readers. They interface with the web browser and provide page details through a tree known as the accessibility tree. YARIA, or ARIA for short, is a standard set of attributes, as I mentioned, for specifying accessibility information. A role says, what is this thing, such as a role of button. Now, you should absolutely use a real button element first, which comes with a role built in. It's also natively focusable, which is super handy. But if for some reason you can't use a button element, and you better have a good reason, the bolt-on role does the same exposing of information as, like the role and the button element can expose the same information. The ARIA state indicates the state of a custom element, such as ARIA expanded or ARIA disabled. A property is anything that isn't a state or a role, such as whether it has a pop-up or an ARIA label. Now, you may think the DOM is slow or have preconceived notions about its value, but these underlying mechanics are a really important part of building for the web platform. It's really important if you are making interfaces that people use, that you understand this underlying semantic information, because it can mean that someone with a disability can actually use your web application. They can be your customer, and that's really powerful. If you want to reference more about ARIA, you can go to the spec, the ARIA spec, which I have bookmarked in my slides. So one example of a browser tool that's enabled by accessibility APIs, which can help you debug your application, is the new accessibility node inspector in Chrome, created by Alice, our expert witness. I've published a resource on how to enable this experiment at bit.ly/chrome-a11y. Developer tools in the browser can help us see how ARIA attributes are exposed. Because simply putting them in the DOM isn't really enough. We need to see how they are exposed through accessibility APIs to know if they're actually having an impact. You can't just make up ARIA attributes or make up roles because there's a standard set. Now, at this time, testing of these attributes is pretty manual. There isn't really a way to test the accessibility tree in an automated fashion. But automated tools can catch common errors, and they promote best practices. And so by following those best practices, you can get it right a lot more of the time than if you were just guessing. All right, Gumshoes, we've successfully uncovered a hidden slice of web development, accessibility APIs. This knowledge helps us by understanding how screen readers interact with the web, and hopefully it illuminates why div soup is so bad. We'll use this information to track down culprits in our next case, so be sure to hang on to your notes. Now, I got a hot tip about testing browser scripts with Node.js. The anonymous source was completely babbling on the phone, but I managed to get the gist. I need you to investigate how we can execute a browser script in Node, keeping in mind they are different contexts with different objects available. Check out this browser script for the Axe core library, a flexible accessibility testing API written in JavaScript. With Axe, you can audit web pages with accessibility rules mapped not only to best practices, but also to accessibility standards like WCAG and Section 508. Having started and never finished an accessibility checker as a side project for myself once, I know how hard this stuff can be. It's pretty challenging. So pulling in a set of rules maintained by people who are experts, who know how to handle edge cases and all of the current state of ARIA and accessibility in browsers, you can pull that power into your projects through an API. because it's actually pretty challenging to make rules that don't have false positives or false negatives. And so that's really where the value of ACTS comes in. It's part of the ACTS manifesto to have no false positives and for the library to be testable itself. But there's an important detail. The ACTS script references objects like window and document to audit the rendered page. To run accessibility checks in Node will require ACTS score, which you can get on NPM. The acts.alicheck API method expects an element context so it can run checks on it, which, by the way, if you see A11Y with numbers in the middle, like an alicheck, our API method, it's a numeronym for accessibility. Here we're passing in an HTML string, but ACTS can also handle element and node references as well as selectors. Let's try the command line and see what happens. So if we run this in a node context, we start hitting errors, unfortunately. The node list interface is undefined, which makes sense given we're in Node, not in a real browser. But what can we actually do here? Let's ask Rainier McChetterton, my Labradoodle, who's a bit of a computer whiz. Rainier, what's the trick to running browser scripts in Node? I think I might have gotten that wrong. I think he's more of a cheese whiz than a computer whiz. Whoops. Anyway, we still have to solve this case. Rainier wasn't much help to us. But you could try running this in a browser, maybe. But that would take us out of the automated testing context and into manual testing, so that's not really what we're after. Maybe we could pass around strings instead of objects since they aren't executed until the right time. I know that works with Selenium WebDriver, where we need to pass an async script off to the browser, so it's not actually executing until we inject it into the browser. But in this case, we're staying in Node, and we're not operating on a browser instance with Selenium WebDriver, so that's not it. If we shim undefined objects, we can reference them in a Node script, so that sounds more likely. And any behavior relying on those shimmed objects should be run conditionally in the browser script so that it doesn't, like even if you pass it in, you can get past that initial failure. Then when we run it, we need to have some more conditional checks to make sure it can be more flexible and be run in the Node environment. So let's go back to our test. As an accessibility testing library for the web, ACTS requires some browser objects to be available for auditing. When we call it from Node with JS DOM, it chokes on a missing node list reference because ACTS assumes it's looking at a browser. And it really needs to look at a browser to test things like color contrast, which really requires the elements to be stacked on top of each other, and you just can't do that in a virtual context. So in our test script, if we use JS DOM's env callback and pass in references to the window, the node, and node list interfaces, that allows us to actually run the script in Node.js. Now, if we run our test, we get actual audit results. So I'm typing in the script on the command line, and then it pulls back the whole results object so we can inspect it. So there's a few violations there, including things like headings need discernible text, the HTML element needs a lang attribute, and an image is missing an alt attribute. Those were the few errors I found in the demo that I tested. But there's still one error thrown there. Document.createRange is not a function. What a jerk. We found another culprit to chase down. Now, we don't have to go too far for these next two cases and to fix that last culprit that we found, but we're going to bust him in the React context. So this is really what you came to see after all, anyway. Gumshoes. A new hire monitoring our servers called to say they were ambushed and the README file was stolen. Now we have no documentation to train the interns. We need your help identifying the browser test engine and restoring the setup. With automated accessibility testing, we have a few options. We need to programmatically perform user tasks to free up human time for more complex testing scenarios. We want to ensure keyboard support in our tests so other developers don't break our stuff and they understand the contract we have for accessibility in our application. We can also catch low-hanging ARIA or HTML markup bugs by having accessibility tests that you might not catch with your eyes. You might see ARIA-roll and think it's valid when it's actually just roll by itself. There are some trade-offs depending on how the infrastructure was set up. It might be really fast, it might be speedy, and you can test a bunch of pages at once, but there are web platform gaps. As we saw with that document.createRange in JS DOM, that was just not supported there. So if we're going to run the full set of tests, we have those trade-offs with speed or web platform support. Using an API allows you to skip writing tests for things like accessible name calculation, which has a lot of edge cases. That hints on that side project I mentioned that I started that I quickly realized how tough it was going to be to write these rules when I got to a form label. And I realized that the label could be in, like, elsewhere in the tree somewhere, and there are a bunch of different ways to label a form element. And so writing a test to tell you that you're missing a label, there's a lot of edge cases there. And if you want to skip that boilerplate in your application, using an API for that, for accessibility test coverage, can give you a leg up. So we need to run unit tests, like this one from the React modal, that ensures escape key support. That's a feature test that we can write for our application that you should absolutely do so that you have custom tests in your application. But if we also want to include an API to just get more test coverage, we can run something like AxeCore. That way, if someone checks in a regression, they'll know about it without having to become an accessibility expert. So there are many ways to configure automated tests, including test runners like Jest or Karma, and frameworks like Mocha or Enzyme. But for this case, we need to configure the browser engine for accessibility tests, which are very intertwined with web APIs, as accessibility can be impacted by multiple parts of the web platform, including CSS display, color, and HTML inheritance. What do we do to make this happen? Hey, a bystander from the Facebook accessibility team, Jessie Beach. Maybe she knows what we're looking for.
The headless horseman rode by and whispered something about needing to be attached.
That's a pretty good clue. But it's still a little vague. So let's see if we can figure this out together. Was it tested with shallow rendering? That works for testing data or things that don't ultimately depend on web interfaces. So that's not going to work for us. It must be full rendering. Jessie said something about it needing to be attached, which for testing accessibility, it's true. We need an attached rendered DOM. This can be done with Enzyme's mount method and attach to option, or you can use React DOM.render with a target, but Enzyme is pretty sweet. They smooth out some of the issues with testing keyboard events and just make it really nice to work with. But even with this approach, there are still limits to what we can test and limits to what has been mocked in JS DOM, as we saw. So for more reliable test coverage for accessibility, look to Phantom.js, which is the headless browser. It has better web platform support than JS DOM. Or if you really want robust coverage, because there are some focus bugs with Phantom, you can look to Selenium WebDriver for integration tests. And those are a bit slower, but they're more robust, and you can really automated test something like a user would use it. And so that eliminates bugs that might come up just because of the testing solution that you chose. But again, there's trade-offs, like Selenium's slower, JS DOM is quicker, but speed versus web platform support. For Enzyme tests, though, if you are looking to do something pretty speedy and in the React environment, I wrote a boilerplate test helper that attaches a React app instance to the DOM, and it runs ax.lecheck, the Ax API method, and then that callback will return accessibility audit tests, or audit results to the test, as we saw in the command line a little earlier. This helper is a work in progress, so if you use it and you run into a problem, let me know. But it shows how you can use Ax and Enzyme together to test a React component. It shims the node interface missing in JS DOM, and it cleans up after itself when it's done. You can find the helper online at bit.ly/A11Y helper. Here's the Alley helper in action. It provides an interface for running Ax audits on React components with the ability to turn specific rules on and off. And that is a standard configuration option in Ax, is that you can feed it custom rules, you can configure it how you want. And this rule, or this test, I'm turning off the color contrast rule because of the issues with JS DOM. It doesn't have support for ranges on the document object. And so by turning that rule off, I can just skip an error that I know exists. I did have to add a timeout to run Ax audits because this is a side effect of testing things with web platform APIs. They're a little bit slower, and I know React devs are a little obsessed with speed. So just a warning, I did have to add a timeout. We're working to improve the performance, trying to figure out ways that we can make that experience better, and we're considering a limited set of tests for running with JS DOM, but you miss out on some of the things that are really valuable, like reporting on color contrast. And so it's a bit of a trade-off. But for now, this is how it can be done with Enzyme. So to review Axe's config parameters and the API, I've bookmarked the documentation at bit.ly/axe-lecheck, or A of 11Y check. I'm ready to escape up that trail here in Utah. I'm pretty excited. But we have one more case to solve. Are you ready? Okay. After the last case, you might be saying, yeah, I know I need an attached DOM for accessibility tests, but they're so slow. What else is there? Allow me to introduce you to ReactX, another tool you can use for accessibility testing in React. It's available on NPM and on GitHub. It works in a similar way to React Alley, which is a known test utility, in that it provides dynamic accessibility feedback right in the Chrome console by monkey patching React internals. This tool, however, as opposed to React Alley, it looks at the actual DOM, the rendered DOM, and uses the same Axe core rule set that you get in unit tests and integration tests and the browser extensions, because there's Chrome and Firefox extensions that you can go and run manually. That's also always an option. But this tool, it's really handy because it will hook in with your React components, and by using the Axe core API on a bunch of different integrations, you can get some consistency with the rules that it reports so that you're all moving towards the same target instead of one person's testing with this tool and someone else is testing with this tool and they have completely different rules that they're reporting to you. Having that consistency can be really helpful in an organization. And it's worth noting that those rules that Axe runs, they benefit from that mapping to the WCAG 2.0 and Section 508 standards, which are the technical and legal standards for meeting accessibility. It's not stuff that you really need to know so much, but it's handy when you're choosing a tool to know that it will help you get closer to compliance. So ReactX is pretty cool. It audits, dedupes, and ranks accessibility issues right in your console. So if you have a bunch that are the same issue, it will group them together so you can look at them all at the same time. It works with ES6, and it piggybacks on React to listen to your application and tell you when something needs fixing. So it cuts down on that feedback loop. Like, you get feedback right away, so in the development process, you can fix it sooner and be in charge of accessibility in your own application. Instead of hoping that someone else will fix it, you can take charge, which is really powerful. But the way that ReactX works is pretty confusing, at least it was to me. There's Carmen. We've got to be close to the source. Okay, so how does ReactX work? Magic! Not really, it's not magic. As we learned earlier, the DOM has to be attached to avoid both false positives and false negatives in accessibility tests. But unlike testing with Axe Core or Axe WebDriver.js, which is another tool that you can use, ReactX does not inject itself into the page. Instead, it uses the React component lifecycle to watch the DOM to be updated, and it can run dynamic accessibility checks against it. By hijacking React.createElement, Axe can piggyback on React and use its same render data to run checks. Because React is sending complete components to the browser, including styles, Axe can safely audit the payload while leveraging web platform APIs. So you really cut down on that feedback cycle and just get information a lot quicker without having to power up another browser. It's right in the one that you're developing in. So that's pretty helpful. All right, well, we kind of got to the bottom of all of our cases. We chased down some seriously confusing stuff today. Like, this is stuff that I have been banging my head against the wall for a while. So hopefully this is really helpful to you as well. But let's review this confusing stuff that we've learned. In screen readers, you might be focusing on an accessible element like an anchor or a button, but it just doesn't land. Check for a race condition or even a bug with assistive technology. It's important to go and check it in the environments that your users are using, even if you use automated tests. Accessibility APIs expose information to assistive technologies, and the semantics that go into your documents are really valuable. So avoid div soup, use native elements wherever possible, and know that there are APIs that take your DOM information and expose it in a programmatic way. When testing browser scripts in Node, be sure to shim global browser objects to prevent errors. You won't really get very far otherwise. You will get blocked by them. But if you start running into those node list errors, things in JS DOM, Go back to the Alley helper that I created, and you can see how to help it a little bit, give it a little hand-holding to run a browser script in Node. We can automatically test accessibility with Enzyme and Phantom and Selenium WebDriver, so you have lots of options. Each one has their drawbacks or pain points, but together we can establish reliable accessibility test coverage instead of having nothing at all, saying, I'll deal with that later. If you work in some tests and make it part of your workflow, you can really move the needle on accessibility and make the web more accessible to people with disabilities. And then lastly, you can test accessibility even faster if you're frustrated with the DOM being slow, or you just want to check out a new shiny tool. You can go look at ReactX and work it right into your React workflow. It's worth mentioning that testing tools are not a substitute for user testing, so be sure that you're promoting that practice as well. But they are a really great start, and they can help you catch that low-hanging fruit that maybe you're just missing because you're human and your eyes are tired, or maybe you aren't as familiar with ARIA. So by using accessibility tests and APIs, you can catch that stuff a lot easier and free yourself up to go do something else. All right, Gumshoes, your first day on the job was such a success. This logical approach to problem solving is very valuable, and we're lucky to have you here at Acme. I hope this builds your confidence in using web development tools to improve web accessibility for everyone. We need more high-caliber individuals, such as yourselves, committed to making a difference. Can I count on you to spread the word about the importance of testing for accessibility? Yeah. I thought so. So I'm Marcy Sutton. I'm a developer at DQ Systems. Couldn't really give that away at the beginning because I'm the chief, actually. But thanks for being a part of my accessibility testing game show, and thanks to the organizers for inviting an Angular accessibility expert to a React conference. If you have any questions or ideas on accessibility, definitely come find me later. I also have some Axe stickers if you'd like one of those. So that's it for me. I'm the chief, signing off.
Where in the stack is Carmen, San Francisco?
I had to play it again. All right, thanks everyone.